So we are taking up an example of a structure which is of uniform thickness. So there are few things. So the density is uniform, thickness is uniform. And then what else we have? Then it is combination of a disk minus another disk. So this is the actual structure that we are trying to figure out. And this is a regular geometrical shape. It's a combination of that. So all of this is taken as given. Okay, I'm not going to write all of those. This is the actual structure. I'll call this as R. This is obtained from the hole. I'll call this as A. A stands for, actually W should have stand for hole, minus a cutout. I'll call this structure as C for ease of conversation. Okay, guys. So first thing first, let me indicate this is your y-axis, that's your x-axis. So do you see any symmetry? So very first thing is, whenever you get any structure, by default it is uniform thickness. Okay. And then next thing is, you will have to look for symmetry. I'll give you guys few clues. Is this a line of symmetry? No, right? If I look left and right of the line, I can see an empty space over here, but there's no empty space over there, so it is not. What about, just a second, it's not getting erased. What about, say, this line? On the left, we have an empty space. On the right, we don't have. Again, it's not a line of symmetry. But if I had a structure like this and the cutout like this, then it would have been a line of symmetry. Then what about the next obvious one? The x-axis. What about now? Is it a line of symmetry? Yes. You can see that if I happen to fold along this line, the structure will overlap and you have a line of symmetry. So first thing is, we have this as a line of symmetry. That's important for us. Okay, so with this, I can conclude the very first thing. Along the y-axis, okay, let me, the y component of center of mass, that is your YCOM. Since the structure is symmetrical along the x-axis, the center of mass is on it. So basically, your y center of mass has to be 0. Where along the 0? Is it here, 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 here? That is still it to be found. Okay. Now, the next thing is, we are looking at your x component of your center of mass. So XCOM. So for that, we have to go to the structure. So I'll assume the radius of this structure. So I'll start with this. I'll assume that this radius is 2r. And this is exactly half of it. That is, this entire thing is 2r. So this will be r. Okay. So this structure is with radius r. So from here till here, its length r. R plus r plus r plus r. So entire diameter over here is actually entire. It's not entire diameter, it's diameter. My bad. Okay, I should not be correcting all of those. You guys don't care. It's not needed actually, that discussion. Just a second. X component, yeah. So these are the assumptions that I make, and now I'll start. So let's consider stamped out disk. So this is the stamped out disk. Back into place as shown in figure 2. Actually, this is single figure, but okay, this is a figure. Now, XA center of mass will be equal to what? It's a full-fledged proper disk, so center of mass will be 0. While the cutout center of mass with respect to this coordinate system, this is 0, 0, is to the left. Remember, right is positive, so left is negative. It will be minus R. Do you guys agree? Quite simple. Now, see, next thing that we'll do is we'll talk about the whole, that is A. It is a combination of, structure, say R, and structure C. So if I combine R plus C, I'll get the whole, right? So with this fact, can I write the center of mass of structure A along the x-axis as per our formula is mr x. This is from your very start. At the start we had done this, right? So that formula, from that formula, can I write this entire expression? I can do a better job actually. I can write it over here and place this over there. Can I do this? And can I write that this entire thing is divided by mr plus mc? Is this correct? Now we're going to substitute the center of mass of structure A is 0. So basically the numerator is 0. So here too, therefore, mr xr com plus mc, the cutout part, this two should add up to 0. You guys agree? Since I'm trying to figure out xr com, I'll just rearrange this a bit. So minus mc by mr into xc com. Again, remember, we know this, we don't know this. But we know one thing about mass. Mass is density into volume. So let's consider the ratio mc by mr. So mc by mr, I can write it as mc by m. The result is combination of A minus C. Again, remember, this resulting disk is a combination of the whole thing minus the cutout. And now using this fact, the density part, I'll rewrite this as density times of volume, density times of volume, density times of volume. So everywhere the density is same. So I can just rewrite this as, then volume can be rewritten as area into thickness, right? So area of C by area of A minus area of C. In both the numerator and denominator, I have taken the thickness common. So this and this will get cancelled, and we have this. Now, this is nothing but area of circle, which is pi r square. That's a general formula. And therefore, we have the ratio mc by mr will be equal to pi. Cutout radius is r, and the whole radius is 2r square minus pi r square. So if I solve this a bit, I'll get 1 by 3, right? Pi gets cancelled. This is 1. This is 3r square. So r square gets cancelled. This is 1 by 3. You guys agree? So this ratio is 1 by 3. X comp is, I'll call this as 1, substituting all of this in 1. Substituting all in 1. Remember, we are trying to figure out x. So minus of 1 by 3. This is minus r. So this is plus r by 3. So basically, if I imagine that I cut this into 3 equal parts somewhere here, this is where your center of mass is. Oh no, r by 3, right? Sorry. This is r. This is r. R by 3 will be somewhere over here. That's where your center of mass is. So this is r by 3, 0. Okay. So all I did was use a bit of math and use our original formula and do a bit of math. This is all simple steps, but I saw to that I write all the steps so that you guys get a good grip on the concept. But next time, I'll just jump from here to this point. Maybe this maximum. The intermediate ones, I'll just skip it. Okay, so yeah. So in this video, we looked at center of mass of a particular rigid object with uniform thickness, and density is uniform. The object density is uniform, right? This is a disk which is cut out. So this resulting disk can be thought of combination of an entire disk minus the cutout disk. So using that fact and symmetry, we have solved this question. So using symmetry, we were able to figure out the y component of center of mass, the y coordinate basically. And when it comes to x coordinate, there's no clear-cut symmetry. So we have to figure out the, exact point. Okay. So how did we do that? We took up the whole center of mass and the cutout center of mass, and we did a few math thing over here, few substitution and all of that. And we made use of the idea that the entire structure is made up of two small structures. And so the center of mass of the entire structure is, we go back to the original formula. And bit of simplification, and we got the answer. Honestly, it's just 2-3 liner. Honestly, it's not that complicated. But yeah, because I wrote so much, it looks big. If not, it's kind of simple.